Hi friends, welcome to all. In this video we are going to discuss CCNA version 7 packet tracer activity subnetting scenario. Before coming to this activity, friends, if you are watching our channel first time or if you like to get these type of technical videos in future, consider subscribing. Also don't forget to enable that bell icon near to the subscribe button so that you will get notification message whenever we upload a new video. And also, if you like to get more technical contents or if you like to contact our team, you can visit our website. Link I given in the description. Now back to our packet tracer activity. Here we can see our addressing table. We have to complete this addressing table. IP address, subnet to mask, and default gateway. And here we can see the objectives of our activity. We will design an IP addressing scheme, then we will assign IP addresses to network devices, and finally we will verify connectivity. In this activity, you are given the network address of 192.168.100.0/24 to subnet and provide the IP addressing for the packet tracer network. Each LAN in the network requires at least 25 addresses for end devices, the switch and the router. The connection between R1 to R2 will require an IP address for each end of the link. Now coming to the instructions, design an IP addressing scheme. Step 1. Subnet the 192.168.100.0/24 network into the appropriate number of subnets. So based on the topology, how many subnets are needed? Coming to our topology, here we can see different networks. So here we can see one network. I think better I will highlight those networks with the different colors. Okay, here we can see one network. Then here we can see one network. Here we can see one network. Here we have one network. So 1, 2, 3, 4 LAN networks, and we have one more network here. So here we can see total 5 networks. So here based on this topology, we need 5 subnets. How many bits must be borrowed to support the number of subnets in the topology table? We must borrow 3 bits from the host portion. So see, when we borrow 1 bit, there will be 2 subnets. When we borrow 2 bits, there will be 4 subnets, and when we borrow 3 bits, there will be 8 subnets. And here we have 5 networks. So obviously we have to borrow 3 bits and we get 8 subnets. Anyways, we will do this subnetting after some time. Now next question here is how many subnets does this create? Yes, already we told that when we borrow 3 bits, we get 8 subnets. Next is how many usable hosts does this create per subnet? Yes, when we borrow 3 bits, we get a 32 IP address, but we get only 30 usable IP addresses because we cannot use the first IP address because it's a network address, and we cannot use the last IP address because that's a broadcast address. Here I show our previous packet tracer activity supporting file, and here we can see the details for /27. I will highlight that line here. Okay, /27, here we can see it's subnet to mask, and here we can see the binary, and we borrowed 3 bits, and here we can see the number of subnets. It's 2 to the power of 3 equals 8. And here we can see the number of hosts per subnet. It's a 2 to the power of 5 minus 2, that is 32 minus 2, it's 30. Now they're given a note here. If your answer is less than the 25 hosts required, then you borrowed too many bits. Okay, anyway, we have 30 usable IP addresses. Now calculate the binary value for the first 5 subnets. The first 2 subnets have been done for you. Now we will do the remaining 3 subnets here. Here we can see they used, they borrowed 3 bits and they given all zeros. Then second subnets 0, 0, 1. So next is obviously 0, 1, 0. And other bit zeros. Okay, now coming to the fourth subnet here, it's obviously 0, 1, 1, then remaining zeros. Okay, then coming to the fifth subnet, it's 1, 0, 0 and all other zeros. Okay, here we will find for all the subnets. So we will find the sixth subnet, it's 1, 0, 1, then all zeros. The next is 1, 1, 0, 0, 0, 0, 0, 0. And the eighth subnet, it's 1, 1, 1 and all zeros. Okay, I think you are clear with this binary value calculations for subnets. Next is calculate the binary and decimal value of the new subnet mask. Now here we will find the subnet mask. So here in binary, first octet all ones, second octet all ones, third octet all ones, and here we borrowed 3 bits. Hence we will give here 1 and here is 1 and here is 1. Next we will give all zeros. Okay, now we will find subnet mask in decimal. Here we can see first octet, it's 8 ones. In decimal it's 255. Then a second octet 8 ones, it's in decimal 255. Same way third octet it's 255. And coming to the fourth octet, here we can see it's a 1, 1, 1, then 5 zeros. So we have to find the decimal for this binary. It's 224. And here we have to recall how to convert from decimal to binary and binary to decimal. We have those videos in our channel. Next, fill in the subnet table listing the decimal value of all available subnets, the first and last usable host address and the broadcast address. Repeat until all addresses are listed. They given a note here, you may not need to use all rows. Okay, our subnet table is ready, and here we are going to find this column subnet address. So we will go to this subnets, and here we can see 192.168.100. all zeros, that means it's 0. So here we can write that 192.168.100.0, the first subnet. Now we will get our second subnet. It's 192.168.100. and here we have to get this decimal from this binary. It's a 0, 0, 1, 0, 0, 0, 0, 0. Obviously its decimal is 32. So our second subnet 192.168.100.32. Now coming to our third subnet 192.168.100.010000000. Its decimal value is 64. So we will update that here, 192.168.100.64. Now the fourth subnet. Next binary is 011000000. So here it's 64 plus 32, it's 96. So coming to our subnet table, 192.168.100, it's 96. Coming to fifth subnet. Next is 1 and 7 zeros. It's obviously easy because it's 128. So coming to subnet table, there is no change in the first three octet, 192.168.100.128. Now coming to sixth subnet, it's here, and here we can see the binary 101, then 5 zeros. So 128 plus 32, it's obviously 160. Okay, coming to our subnet table, here 192.168.100.160. And coming to a seventh subnet, it's a 1 then 6 zeros. Its decimal is 128 plus 64, it's 192. 192.168.100.192. Now coming to the last subnet, the eighth subnet. Here we can see the binary 111 and then 5 zeros. It's obviously 128 plus 64 plus 32. It's 224. So coming to our subnet table, and we will update this 8th subnet address, 192.168.100.224. Now very easily we can find these first usable host address, last usable host address, and broadcast address. So here the first usable host address is the next address, that is after 0 it's 1. Now we will find the broadcast address. Before that, here we can see the second subnet address, it's 100.32. So here we will get the broadcast address, it's 100.31. Now we will get last usable host address, it's 1 less than broadcast address, it's 100.30. In the same way, we can find these details for other subnets. Here is the first usable host address, it's 100.33, and here the broadcast address, it's .63, and here we get last usable host address, it's 62. Next is first usable host address, it's .65. Then the broadcast address, it's 100.95, and last usable host address, it's .94. Coming to the next subnet, first usable host address, here is the broadcast address, and here we have last usable host address. Next subnet is first usable host, it's 129, and here we get the broadcast address, it's 159, and here is the last usable address, it's 158. Next is 161, here is broadcast, it's 191, and last usable host address, it's 190. Next subnet, first usable host address, it's 193, and here is our broadcast address for this seventh subnet, it's 223, and here is the last usable host address, Now coming to the last subnet, the 8th subnet, first usable host address 225, and here we get broadcast address, it's 255, and here is our last usable host address, it's 254. Here we are ready with our subnet table. Now we will go to step 2, assign the subnets to the network shown in the topology. Okay, assign subnet 0 to the LAN connected to the gigabit Ethernet 0/0 interface of R1. So coming to our topology, here we can see that gigabit Ethernet 0/0. Assign subnet to 1 to the LAN connected to the gigabit Ethernet 0/1 interface of R1. Okay, here we can see that network. Then assign subnet 2 to the LAN connected to the gigabit Ethernet 0/0 interface of R2. Here we can see R2 interface gigabit Ethernet 0/0. Now assign subnet 3 to the LAN connected to the gigabit Ethernet 0/1 interface of R2. Here we can see that network gigabit Ethernet 0/1. Then assign subnet 4 to the WAN link between R1 and to R2. Okay, here we can see that. We will document our addressing table using this step 3, document the addressing scheme. Fill in the addressing table using the following guidelines. We are ready with our addressing table in our spreadsheet. Now, assign the first usable IP addresses in each subnet to R1 for the 2 LAN links and the WAN link. Here we have seen assign subnet 0 to the LAN connected to the gigabit Ethernet 0/0. Okay, so coming to our spreadsheet and coming to subnet table, here we can see subnet 0, and here we can see our first usable host address. We will copy this address and we will assign for this interface gigabit Ethernet 0/0. And here we have to give our subnet to mask. Okay, it's here. You will give that here 255.255.255.224, and here default gateway not applicable. Okay. Next we can see assign subnet to 1 to the LAN connected to gigabit Ethernet 0/1. So here we have to get the first usable host address from this subnet number 1. So it's here. We will copy this and coming to our addressing table on R1 gigabit Ethernet 0/1, we will give this IP address, and here is the same subnet to mask and default gateway not applicable. Next we can see assign subnet to 4 to the WAN link between R1 to R2. So we have to use the subnet 4. Coming to our spreadsheet, subnet table, here we can see subnet number 4, and here is the first usable host address. We will copy this address. Coming to our addressing table, and we will give this IP address to this interface serial 0/0/0 on this router R1. And here is our subnet to mask, default gateway not applicable. Now coming to R2, assign the first usable IP addresses in each subnet to R2 for the LAN links. Assign the last usable IP address for the WAN link, because we already used the first usable IP address for this interface serial 0/0/0 on this router R1. We can do that, and here we can see assign subnet 2 to the LAN connected to gigabit Ethernet 0/0 of R2. Okay, coming to our spreadsheet, coming to subnet table, here we will use this subnet number 2. Then we will copy this first usable host address and we will assign to gigabit Ethernet 0/0 for this device R2. same subnet to mask, and here a default gateway not applicable. Next, here we can see assign subnet 3 to the LAN connected to the gigabit Ethernet 0/1 interface of R2. So we will get the first usable address from this subnet number 3. You will copy this address, and coming to IP address for this interface G0/1 subnet to mask same, and default gateway not applicable. Now for the interface serial 0/0/0 on this router R2, we have to use the last usable host address from this subnet number 4, and here we can see that address. We will copy it, and coming to our addressing table, here is the IP address and subnet to mask default gateway not applicable. Okay, now we will go to the next requirements. Assign the second usable IP address in the attached subnets to the switches. That can be done here. Keep in mind we have to assign second usable IP address. Okay, coming to our spreadsheet, here we can see device S1, so which is connected to G0/0. So we assign the first usable host address here for this interface. So second address, it's 100.2, and here is the subnet to mask, and default gateway, obviously the IP address of this interface gigabit Ethernet 0/0. So it's here. We will copy that. Next is S2. Coming to our topology, here we can see S2 is connected to gigabit Ethernet 0/1 of this router R1. So coming to G0/1, here we can see we used the first usable host address here. So here the next usable address is 34, and here is a subnet to mask, and the default gateway, the IP address of this interface G0/1. Next we can see S3, which is connected to G0/0 in this router R2. R2 G0/0, here is our first usable IP address, which is already used for this interface. So now we will use the the second usable IP address here. It's 65. No, it's 66, because 65 we used. It's 66, and here is subnet to mask, and default gateway, the IP address of this interface gigabit Ethernet 0/0. Now coming to our last switch, S4, and here we can see S4 is connected to G0/1 in this router R2. Okay, G0/1 on R2, here we used the first usable host address. So now we have to give a second usable host address for this S4. It's 98, and here is the default gateway, then same subnet to mask. Now we have to assign IP address, subnet to mask, and default gateway for these PCs, PC1, PC2, PC3, and PC4. We will check the requirements. Assign the last usable IP addresses to the PCs in each subnet. We can do that very easily. So coming to subnet table, here we can see last usable host address from this subnet number 0. We will copy this address. Coming to addressing table, assign to PC1. Then here the default gateway, it's 100.1. Then the subnet to mask, same. Coming to PC2, last usable host address from this subnet number 1. Addressing table, okay. Then it's default gateway, it's here. Then it's subnet to mask, and next is from our subnet table, from subnet number 2, last usable host address, we will copy this IP address. Coming to our addressing table, and here we have to give its default gateway. It's a 65, the IP address of a gigabit Ethernet 0/0, and it's a subnet mask. Now coming to the last PC, PC4. So here coming to our topology, here we can see PC4. This network is connected to this interface G0/1. So obviously the default gateway for all these devices will be the IP address of this interface, that is G0/1 in this router R2. Okay, so coming to our spreadsheet, here we will go to subnet table, and here we will get the subnet number 3, last usable host address. It's here. We'll copy that. Coming to our addressing table, and here the default gateway, it's here. Then the subnet mask. Okay, now we updated our addressing table. It's ready to use. In part 2, assign IP addresses to network devices and verify connectivity. Most of the IP addressing is already configured on this network. Implement the following steps to complete the addressing configuration. EIGRP dynamic routing is already configured between R1 and R2. Here don't worry about this dynamic routing, because we will see this dynamic routing in the forthcoming packet tracer activities. Now we will go to step 1, configure R1 LAN interfaces. Configure both LAN interfaces with the addresses from the addressing table. Then configure the interfaces so that the hosts on the LANs have connectivity to the default gateway. We will do that. First of all, we will configure this interface gigabit Ethernet 0/0 on this router R1. Okay, so we'll come to R1. Before that, we will get the IP address for this interface. We will copy this address. Coming to CLI, enable configure terminal. Okay, here I'm using this tab button to complete this incomplete unique command. So just I would like to say, don't confuse how these commands coming in different lines, because here we use this tab button. So now we will go to specific configuration mode. We will go to the interface gigabit Ethernet G tab, then 0/0, and here we are going to set the IP address AD tab. Then we have to give the IP address. We already copied the IP address. We will paste here. Then we have to give its subnet mask. It's here. So we have to give it correctly. Now we have to give no shutdown command so that this interface become up. Now here we can see the link between these devices R1 and S1 is up. Now we will go to the interface gigabit Ethernet 0/1. We will exit, then we will go to the interface gigabit Ethernet 0/1. Then we will set the IP address as per our addressing table. Here we can see its IP address. We will copy it. Then coming to R1 CLI IP address. Here is the address. Then its mask 224. Okay, then no shutdown. Here we can see the link between these devices R1 and S2 is up. Now in step 2, configure IP addressing on S3. Configure the switch VLAN 1 interface with addressing. Configure the switch with the default gateway address also. Okay, we will close this R1 and we will go to S3. Okay, here is S3. We will go to CLI and we have to get the IP address of S3. Here we can see that. We will copy this address and Coming to a switch, enable configure terminal, we will go to the interface, virtual LAN vlan 1, and we will set the IP address, management interface. Okay, now it's subnet to mask 224. We have to give a no shutdown command. Next is step 3, configure PC4. Configure PC4 with the host and the default gateway address. Oh, before that we have to configure this switch default gateway in S3. Okay, we can do that. We forgot that. So we'll exit from this mode. Then here we will set a default gateway, IP default gateway. So we have to get its default gateway S3. It's here. We'll copy this address and here we'll paste it, then press enter. Okay, now we will configure our PC4. So we will get its IP address PC4. It's here, and it's subnet to mask and the default gateway. Coming to PC4 desktop, we have to go to IP configuration, and here is its IP address. Now we have to change this default subnet to mask to 224. Now we have to give its default gateway. It's here. It's ready. Finally, verify connectivity. You can only verify connectivity from R1, S3 and PC4. However, you should be able to ping every IP address listed in the addressing table. Okay, here we will ping from PC4 to other PCs, PC1, PC2 and PC3. So we will get the IP address of PC1 first. Then coming to PC4, command prompt, here we will ping to PC1. And here we are waiting for the replies. Maybe we get one request timed out or two. Here we can see it's working. Now we will get the IP address of PC2. It's here. We will ping to PC2. It should work. Request timed out. Yes, we get the replies. Now we will get the IP address of PC3. Ping to PC3. Request timed out. It's working. Also, we will try to ping to a router and to a switch. So we'll get the IP address of our switch S3. Ping to S3. We are waiting for the replies. Request timed out. Maybe one or two request timed out. Oh, it's working. So once more we will give that. It's working. Now we will get the IP address of R1G0/0 interface IP address. Then we will ping to that interface. It's working. Here we can see our completion status. It's 100%. So friends, in this video we discussed the packet tracer activity subnetting scenario. Now dear friends, if you have any doubt, any suggestions regarding this packet tracer activity, please comment below. Also, if you like our video, give a thumb and share with all your friends. Also, don't forget to visit our website, link I given in the description. So we will meet again with the next video. Thank you.